in terms of multiplying radicals. If I said this, that is, don't overthink. Root 6. Like we've been, when we simplify radicals, you know, like if, let's say we're asked to simplify root 24, we find the highest perfect square, which is 4. And then the other radical has to be 6 because 4 times 6 is 24. Right? So you guys have actually been doing multiplying. If I said this, root 12. What's wrong with that? Is that a final answer? Remember, when we deal with radicals, if you can simplify it by finding the highest perfect square, do it. Highest perfect square that goes into this? 4. And 4 times what is 12? And therefore this becomes 2 root 3. Last one, before I move on to the other examples. Root 4. How about this? What's that? Root 2? It's what? It's just 2, isn't it? Isn't the square root 4 just 2? You don't simplify it, you can take it. Exactly. Okay? That actually happens whenever you multiply a radical by itself. The answer is always the number under the radical without the root. So there's 3 different situations. You can multiply, get a radical, and stop, because you can't do anything with it. You can't take it exactly. You can't simplify it. Multiply a radical, get an answer that you can change to a mixed radical. Or multiply radicals, get an answer that you can take exactly and get a non-radical. Keep those in mind as we do these. So the general rule is when we have a radical and we multiply it by another radical with the same index, so they have to be both square roots or both cube roots, etc. You can make that into one radical by just multiplying the numbers underneath the radical. Okay? I'll talk about this in a second. So, what's root 6 times root 10? It's root 60. Can I do anything with it? Can I take it exactly? Can I put it down to a mixed radical? Is there a perfect square that goes into it, or can I take it exactly? You're nodding. Which one? Okay. Highest perfect square? 4. Which means the other number must be 15, which means that's the final answer we get. 2 root 15. Good. Don't let the numbers, if there are numbers in front of the radical, don't let them throw you. Okay? This is the same as root 3 times 4 times root 15. That's what it means. Well, remember when we multiply a whole bunch of stuff, the order that we multiply doesn't matter. So I'm going to put the non-radical first, and then the 2 radicals. And I can multiply those 2 radicals into a single one. What do I get? 3 times 15. 45. And I don't need the multiplication signs. So now, do I stop? Can I take it exactly? Can I break it down? Is there a perfect square? 9. So root 9 times root 5 equals 4 times 3 root 5. And I can go a little bit further. 12 root 5. Stop that. I know. I don't know. It was cold at the beginning of the year, and now all of a sudden it's a stop. Okay. Multiply the non-radicals. What do you get? -6. Multiply the radicals. What do you get? Root 40, and those are getting multiplied. So that's really what we're doing. Can I break it down? Or take it exactly? Four, so root 4 times root. There, 10. Which equals -6 times 2 root 10. Which equals -12 root 10. Good. This is the one I want to start, and it goes to the note above. If we multiply, so we're going to get, if we multiply, we're going to get 8 times root whatever 7 times 75 is, right? That's a really big number. And that would be hard to simplify, wouldn't it? So whenever you get really big numbers, simplify first if you can. I can't do anything with 2 root 7. But I can simplify root 75. Highest perfect square into 75, 25, which means the other radical must be 3. So that gives me 2 root 7 times 4 times 5. Because I can multiply 4 times root 25 to get 20 root 3. That's a lot easier. Just multiply the non-radicals, multiply the radicals, and then put those together by multiplication. So 2 times 20 is 40. Root 7 times root 3 is root 21, and they're beside each other to show multiplication. Okay? So sometimes it may be easier to simplify first before multiplying. Because it will avoid big radicals that are much harder to simplify. Okay? So just keep on the lookout for that. All the questions we've done are square roots. Works with cube roots too, as long as they're both cube roots. What would you get if you multiplied these two together? Cube root 54. Remember, don't forget the cube root. common mistake students make is they always think they're dealing with square roots. Can I break this down? Remember, perfect cubes now, not perfect squares.
27 and 2.
27 and 2, thank you. And the cube root of 27 is 3. And beside that, we put 3 cube root 2. Final one on this page. Multiply the non-radicals, what do you get? -8. Multiply the two radicals, what do you get? 22 y to the 4th. Excellent. What do I do when I have a number and a variable inside? Split them up. So we get -8 times root 22 times root y to the 4th. Can I simplify root 22? Perfect square goes into it? Yes, no? Like you get perfect squares. Does 4 go into it? 9? 16? Well, now I'm over 22. So I can't. How about this one? Okay, you're on the right track. What times itself? We can actually take this one exactly. What is it? What times itself gives us y to the 4th? Remember, think exponent laws. What little number plus itself equals 4? What little number plus itself equals 4? 2. I can't hear you. And then put the non-radicals beside each other and put the radical at the end. Any questions? Yeah.
So is the y square included in that square root 32 or is it
In the square root?
the step above? Is this like?
No, it's not. The square root only goes around 22.
So it's how that like multiply?
Yes, yes, that's right. Okay, example 2 I want to look at. What do you think you would do here? What's this? Sorry? 2xy? 2x plus 2y because I have to do 2 multiplications, right? Same thing. I just have to do 2 multiplications.
Is there root 3?
What's that? This whole thing, like you're going to multiply this by this, and then this whole thing by this. So what's 7 root 3 times 5 root 5? 35 root 15. Good. Plus 7 root 3 times 6 root 3. 42 root 9. Now I got to see if I can do anything with these radicals. Can I simplify this at all or take it exactly? Is there a highest perfect square that goes into 15? No. Can I simplify this or take it exactly? Which one? It becomes 3, doesn't it? So this is actually 35 root 15 plus 42 times 3. which gives us 35 root 15 plus, and I'm assuming you can do this either with your head or on the calculator, 126. Multiplications again for b. When I multiply these two, what do I get? Negative 6 root 22. When I multiply these two, what do I get? Positive 8, sorry, root 12. Okay. Can you do anything with either one of the radicals? Which one?
Second one would be.
Yeah, we can break this one down. So root 4 times root 3, which becomes 2 root 3. Negative 6 root 22 plus 16 root 3. Okay. And the last one, don't let the variables throw you. This time we're going to do 3 multiplications. What is root k times root k to the third? Root k to the fourth minus root k times 2 root k. And root k times 1. Don't overthink. Just root k. Highest perfect squares to simplify, or can I take them exactly? What about this one? Not root k2, just k squared. Because you're taking the square root, therefore it's disappearing. Minus 2, this one. Okay. And I can't do anything with the third term. So that's as far as I can go. And I can't collect any like terms. Okay. So you see the importance of being able to simplify radicals, of being able, especially square roots. Okay. If you are having difficulties simplifying radicals, finding the highest perfect square, if it takes you a long time, here's another potential way to do it. Let's say I want to do this. Okay. What we do is we break down, we do it like a factor tree. Okay. Think prime numbers. Lowest prime number is 2, then 3, then 5, then 7, etc. What's the lowest prime number that goes into 44? I just wrote it. Next time. And this would be 22, right? Can't simplify this anymore. But I can break this down. What's the lowest prime number that, notice I'm writing square roots over. What's the lowest prime number that goes into 22? 11. Oh, 2. I keep, oh. Can I go any further? Doesn't this make 2? If like this times this times this, isn't this times this 2? And I can't do anything with this? Done. Doesn't mean you have to do it this way. I'm just trying to show you another way where you don't have to think of higher perfect squares. So like if I said this, remember with some of them, sometimes there's more than one perfect square. Well, I would go, okay, root 2 is the smallest, and it's 16. Can't do anything with root 2. I can go root 2 again, and it's root 8. Can't do anything with this, but I can go again here. Root 2 times root 4. Okay? Well, that's 2. That's 2. And that's root 2. So 2 times root 2 times 2 is 4 root 2. Again, you don't, it's just another way to do it if you're having trouble with highest perfect squares. Okay, maybe some of you might want to do this for big numbers. And then for small numbers, you can do those in your head, like root 12 or root 18, ones like that. Okay, just an option. I'm not going to say simplify this and you must do it this way. You do it the way you're comfortable with.